Good morning, one and all. My name is Devika. I am from VNR VJIT. Today, I am going to tell about transaction, a topic on transactions. So, basically, what is a transaction? So, you might have been come across this word in many cases where transaction has been used in banks and everywhere in shoppings, etc. So, basically, what is a transaction in DBMS? So I can define transaction as group of task. So what is task? Coming to task, it is a small unit processing where which cannot be divided further. So when you take any kind of transaction, it is considered as a single unit which cannot be divided further, right? So when I come across or when we have many number of single tasks at all together, then it is known as transactions, or you can also define as collection of operations that form a single logical unit is nothing but your transaction. So basically, when we consider in DBMS, for each transaction we are having a begin transaction and end transaction. Begins transaction states when a transaction has been started, and end transaction specifies the timestamp where the transaction has been enclosed, right? So when we consider all the tasks that are between begin transaction and end transaction, which complete the total transaction. So when we consider about transactions, we should be aware that we should be known that each transaction should be done completely, right? So in order to ensure that transaction has been completely done or not, each transaction should ensure these ACID properties. What are these ACID properties? A stands for atomicity, C stands for consistency, I for isolation, and D for durability. So what is this atomicity? Atom. If I consider, yeah, I can take from the word called atom. Generally, atom will not be divided further. So in the same way, transactions as defined earlier, that each transaction is considered as a single task. So atomicity refers that which cannot be further divided. So there is no state in database where transaction is left partially. Each transaction should be done completely. You cannot wind off, or you cannot stop any transaction in the middle or partially, right? So we are having some states of transactions as well, which will be covered in the next topic. Next one is consistency. What is this consistency? Consistency means like whenever you have entered for 5,000, so you must get, it ensures that 5,000 amount, whatever you have entered, that amount is coming as an output, right? So whatever the transaction, whenever we are trying to do, it must have a consistent state. It should be accurate. So that is all about consistency. Coming to durability. Durability means the basically whenever you come across this database, it should hold all the latest updates, right? So even the system fails or restarts, it should ensure that your data is safe. So like if you have come across this transaction and suddenly you haven't, for example, if you have entered 5,000 amount of money and suddenly there was a power cut, right? So even though if you don't draw the money back in your account, it must ensure that 5,000 is safe. So that is durability. Next is isolation. What is this isolation? Isolation means like in database system, we treat each transaction, even though they are being simultaneously performed, each user will think that this transaction is being done by a single person, right? So that is known as isolation. So this is a simple transaction model where we are having two operations. Mainly transaction have two operations, that are read operation and write operation. So we define each and every transaction with two operations, that is read of X. So read is one action that is performed on data item X. So X is your data item. And as I said that each transaction is having some active states, right? So these are following states that are being present for a transaction. First one is active state. partially committed, failed, aborted, and committed. If you see this figure, you can have a clear understanding. So how the connection between active, partially committed, failed, aborted is present. So active, what does active means? This is the first state whenever a transaction happens. So transaction happens, or when we try to perform a transaction, it is the first state. So first state is active transaction. So once it is active, it can enter into partially committed, or due to some failures, it enters into failed state. After partially committed, what is this partially committed? When we perform a transaction and if we don't commit that transaction, it will store in temporary database. It is not saved in permanent database. So that is partially committed. So once the transaction is completely done perfectly, then the total data related to transaction is saved in permanent database and the transaction is said to be end. Coming to the other end of the transaction state, that is failed. So due to some issues, if your password is wrong, or due to some database issues or power failures, if the transaction is failed, it can either enter into partially committed or it can be aborted. Okay, so after aborted, you need to reschedule your transaction. Again, you can perform transaction, right? So that are the important states of your transaction. Next one is schedule. What is this schedule? Why we are going with schedule? As you all know that we can perform many transactions. So per day in an ATM or any banks, there are many schedules or many transactions are being performed. So whenever we are trying to maintain a database, we must ensure that all the transactions are performed or maintaining a schedule. So schedule is just like a timetable, right? A timetable will be having different times of classes, at what time a class has been started, at what time a class has been ended. In the same way, schedule is also a collection of transactions, when the transaction has been started, when the transaction has been completed, right? So we are having two types of schedules, that is serial schedule and parallel schedule or non-serial schedule. We can term it as parallel schedule or serial schedule. So this is types of schedule and which are further divided, like serial schedule, non-serial schedule. Again, non-serial schedule is divided into serializable, non-serializable, where serializable is again divided into conflict serializable and view serializable, and etc. So this is an overview of what are the schedules that are present in DBMS, right? Coming to parallel schedule, right? When I tell what is serial schedule, just like serial, each transaction performs one after the other, right? So there is no conflicts, there are no problems, no issues with any kind of serial schedules. Coming to this parallel schedule, what is this parallel schedule or non-serial schedule, right? So in this non-serial schedule, multiple transactions perform concurrently. So one time a transaction will be performing some read write action, and once it gets halted, the other transaction will start read write operation. So all the operations of the transactions are interleaved or mixed with each other. So in serial, there are in non-serial there are chances of conflicts. There are some possibilities of conflicts in non-serial schedule. Okay, so next one is how to overcome this serializability or how to overcome these conflicts. We are having a concept called serializability. What is the serializability? Serializability means we must ensure that all the transactions are being performed serial. So when a transaction is being performed, we don't know whether it is going to perform serial or non-serial. So to find out whether each transaction is being performed serial or non-serial, we must there are many methods to calculate this. So there is a view equivalence, there is conflict equivalence, and the other one is we are having uh, other kind of equivalence, right? So views equivalence, it ensures that both schedules look similar and perform similar. If you find any two transactions that have been started and that are being performed and that are being ended in the same sequence, then we can say that it is view serializability. Coming to conflict serializability, as I said that when you go with non-serial schedule, it ensures or they may happen some conflicts. So what type of conflicts? They are determined by four problems. One is dirty read, one is unrepeatable read, next one is lost update, and fourth one is Pantheon read problem. So we will be continuing what kinds of this concurrency problem, how to find it out, what kind of concurrency problem a transaction have, and how to recover that in the next class. Thank you.